All right, so this is, if you're flipping around, page 44. So now, I have told you the breakdown of the problems on the test, so a lot of it is not a mystery. So when you're talking about, for example, this question here, like how do I know on the test whether to use a trig substitution? Well, number 7, integration using a trigonometric substitution. All right, so there's your indicator. So that will be question 7. Also, I tend to draw the triangle for you, just to save you that one little piece of effort. Actually, I throw that in there, honestly. I throw that in there because in the past, 80% of the class has screwed up the problem related to trig substitutions simply because they didn't have the triangle drawing. And so when they got to the part where they successfully found the integral and they got something like sine of theta plus theta, and they just left that as their final answer. Even though it's supposed to be an algebraic result, because they didn't have a triangle to look at to pull all that information out of. So it's like kind of a helping hand that I'm offering.
So this is in order?
Yeah. Just the little things in life. But very useful piece of information to know. So for the good of everybody else who might have been wondering the same thing. Yes. I'm gonna 1 plus x squared, and then so I'm reorganizing into the first galactic empire. That was an easy one. Movie reference? Episode 3. Yeah, the part where he actually made the empire. Yeah, I mean, that was kind of for a safe and secure society. That's how he spoke for some reason. Apparently, he's a really nice guy, Ian McDermott. Anyway, so I'm cleaning it up, writing it in this format for a very, very specific purpose. That purpose is to make it look as much like an inverse trig rule as possible. All right. I look at my inverse trig rules. They all seem to lead with the constant except for the secant one. The secant one has a minus sign in it. In fact, the only one that has a plus sign in it, the only ones that have plus sign in it are tangent and cotangent. Prefer to work with the tangent one wherever possible. So I have it in that form so that it at least seems a little bit more like one of those rules. All right. Say it again? It is, but the radical is taking the place of the denominator too, yeah. All right, so I'm going to define my u and my a. So this is going to give me u equal to x. And this is going to give me my a equal to 1. And again, I always operate under the assumption that people just don't like memorizing rules because everybody must be like me for some reason. That's what goes through my mind. No, some of you love memorizing rules. So I have a u and an a. I'm going to place them appropriately on the triangle. I can place them any way that I want, provided that the missing side is a radical 1 plus x squared. All right. So I might get a tangent. I might get a cotangent. It doesn't matter as long as the missing side is radical 1 plus x squared. So I'm going to put my x here and my 1 there. Using Pythagorean theorem, I get 1 plus x squared under the radical. I didn't trust myself to make that one further away. Less. Sorry. Say that again.
You just put the 1 and the x, or we put them based on opposite or adjacent?
As it turns out, yes, but I put them there because I knew that when I used the Pythagorean theorem to find the missing side, it was gonna give me the radical 1 plus x squared. I care about what the radical is gonna look like when I place these appropriately. So if I put the x here and the 1 there, I would have gotten radical x squared minus 1, and that's not the radical I need. So as long as you have placement that allows the missing side to be the radical you're looking for, you're in good shape. All right? So then what we're going to do is we're going to find a ratio of the variable to the constant. And simultaneously, we're going to find the ratio of the radical to the constant. The variable is my opposite side. The constant is the adjacent side. So that's giving me the tangent ratio. Tangent of theta is equal to x over 1. So there's x. The radical is the hypotenuse. The constant is the adjacent side. That's the secant ratio. And that would be the radical 1 plus x squared over 1. I don't need to write the over 1. Oh, these are just rules. Yeah, and then from there we get these ratios, but these are just rules that you need. So then I have a direct relationship for what I wrote in purple. That's good to go. I don't need to manipulate that at all. The other one I want to differentiate. I'm going to write it first. Write it or think of it in this fashion, x equals tangent theta, and then take the derivative, dx equals secant squared theta d theta. So now we can perform our trig substitution. So antiderivative 1 over, now that whole radical business is out. That's now secant theta cubed. The dx is out, and now that's secant squared theta d theta. This is going to clean up beautifully. It won't be, it'll be like just the way you draw it up in the playbook. It is stunningly gorgeous when we clean this up. It's provided I can make an equal sign effectively. Close enough. All right, so secant squared over secant cubed, that's 1 over secant, the same as cosine. The antiderivative of cosine, sine. So now I just need the sine ratio. That's why I draw the triangle, because more often than not, I gave the 80% number. That's anecdotal. I just pulled that off the top of my head, but it can't be far from correct. Roughly 80% of the class will leave this as their final answer and call it a day. The question is in terms of x. The answer needs to be in terms of x. Question?
Yeah, just for the integral, that's just an equal sign, right? It's not negative.
Correct. So now, back to the triangle. Again, from our reference angle, we have an opposite side, we have an adjacent side, and we have a hypotenuse. Try to make it look a little bit better. Oh, I just can't. I try. So Sine is opposite over hypotenuse, so x over the root of 1 plus x squared plus c. This question is like the poster child of why we learn trig substitution, because it took something that was just hideous and made it something that we can take the antiderivative of very, very easily. Right? This is a basic rule, very basic rule. It's just getting from that piece of information back to the appropriate form. That's where people, if they're gonna trip at the finish line, that's the finish line. So that's where the tripping is gonna happen. Not that kind of tripping, like actually tripping and falling. So I think that gets its own video. Page 44, number 3.